Welcome to part 3 of Unbinding Prometheus, how generative AI liberates computational thinking from coding. In this part, I'll explain how generative AI enables no-code computational thinking by reasoning with natural language instead of code, demonstrating this approach via an example of scheduling professors into working groups at a faculty retreat. I also show how AI is democratizing computation through prompt engineering and vibe coding, turning ideas into working solutions via conversations and reshaping education, creativity, and the very definition of programming itself. Let's start with an example of what no-code computational thinking looks like in real life, showing how generative AI can take on a task that used to feel tedious and error-prone. A few years ago, back when ChatGPT was still brand new, I co-chaired a computer science faculty retreat at Vanderbilt. We'd asked all 35 professors to send us one sentence about what topic they wanted to discuss. My co-chair proposed we read them all, group them by hand, and then manually assign everyone to one of 5 discussion groups. That sounded like a long afternoon of spreadsheets and coffee. So instead I said, let's have ChatGPT do it. In seconds, it clustered the topics perfectly. Then, after each professor ranked their top 3 choices in a Google form, I fed the results back into ChatGPT, and it quickly balanced every group by interest and size. What once took hours of sorting, formula tweaking, and programming became a 10-minute conversation with generative AI. It was computational thinking without code, problem solving through natural language instead of syntax. That's the quiet revolution that's happening right now. Here's the record of the conversation that I had with ChatGPT. I started by giving it a data set, a list of all 35 faculty members and their top 3 topic preferences. ChatGPT thought for a moment and then announced that it would use a greedy algorithm to assign faculty to their preferred topics, which seemed reasonable. However, greedy algorithms tend to get a little greedy. Some topic areas filled up too fast, and a few unlucky faculty didn't get assigned to any of their preferred topics. Most notably, Jonathan Sprinkle ended up in a topic area he didn't even want, simply because his request came in last. Now, in the old days, that would have meant rewriting the Python code, debugging it, rerunning it, and testing again. But this time, I just told ChatGPT, your greedy algorithm gave Jonathan Sprinkle a topic he doesn't care about. Please come up with a better allocation. ChatGPT tried again and still didn't get it quite right. So I nudged it once more. This time it paused, thought a bit longer, and replied, I'm going to use randomization. And voila. The new approach perfectly allocated everyone, including Jonathan, to one of their actual preferences. It took a few iterations, but what would have been hours of manual coding and debugging turned into a few minutes of no-code computational thinking, simply guiding the AI through reasoning steps with natural language. Let's now step back and examine the 3 layers of computational thinking that generative AI is commoditizing. We'll start with the first layer, problem abstraction, where AI helps convert messy, vague ideas into something structured. You might start with a fuzzy concept, a cloud of question marks, and through a quick back and forth with a generative AI model, you can sharpen your idea into a clear, well-defined prompt. It's like having a thought partner who translates your intuition into a plan of action. The second layer is automation design. Once the problem is clear, AI scaffolds the logic for you. You don't have to write code line by line. You just describe what you want to happen in natural language, such as, if this happens, then do that. AI connects the blocks, sketches the algorithm, and shows you the workflow that previously took hours of manual programming. Finally, the third layer is tool implementation. Here, AI takes the automation design and makes it real. It writes the code, runs the analysis, builds the simulation, and even visualizes the results. We're seeing a dramatic shift. You can now move from a vague idea to working results almost instantly. Moreover, people are increasingly skipping straight from problem to outcome, bypassing traditional coding entirely. That's the magic of generative AI. and the disruption. Computational thinking itself is being democratized and commoditized. Anyone with a browser and curiosity can now think and create computationally. So what does all this mean for the future of computational thinking and computer science education? For starters, it means the future increasingly belongs to those who can ask the right questions and then use AI to model their ideas computationally. We're entering an era where problem solving feels less like coding and more like conversation. You describe what you want. Maybe it's generate an app that optimizes my workflow, and AI takes it from there, abstracting the problem, designing the logic, and implementing the solution. This new paradigm of prompt engineering is often called vibe coding, creating through intuition, not syntax. It's about shaping experiences and systems with natural language and imagination, rather than wrestling with lines of code. In the vibe coding paradigm, creativity becomes the new literacy. If you can imagine it, describe it, and refine it through dialogue with AI, you can build it. That's where computational thinking is headed, from programming machines to partnering with them. There's a terrific article by Tim O'Reilly titled AI in Programming, the Beginning of a New Era, where he argues that we're not witnessing the end of programming, but its remarkable expansion. His central idea is simple but profound. Thanks to vibe coding, the cost of trying new ideas has dropped by orders of magnitude. What used to take days or weeks can now be created and tested in minutes. Students, researchers, and even people with no coding background at all can now describe an idea in natural language and get a working prototype almost instantly. However, this doesn't mean we're handing over our most critical systems to AI. No one's suggesting we build a heart monitor or a nuclear reactor with vibe coding. Yet the rise of generative AI has dramatically expanded the addressable surface area of programming, transforming it from a narrow domain for specialists into a vast, interconnected landscape where educators, writers, designers, and scientists can all express ideas computationally. What was once a small circle of programmers has rippled outward into a global creative ecosystem, bridging traditional coding islands like C++, Java, and Python with new continents of natural language interfaces, prompt engineering, design synthesis, and no-code tools. Ultimately, this expansion is good news for computer scientists and software engineers. Vibe coding doesn't replace software professionals. It broadens the on-ramp and lets more people think computationally, experiment boldly, and build the future faster than ever before. As the wave of rapid prototyping grows, the best of these AI-generated ideas must be refined, hardened, and scaled by experts who understand systems, architectures, dependability, security, and performance. Maybe it's time to rethink how we teach computer science. Begin with the magic of AI, then pull back the curtain to reveal the rigor behind it. I've been thinking a lot about how vibe coding could redefine the entry point to our field. Imagine a CS 100 course, a prelude to the traditional CS 101, built entirely around AI-driven creation. Students wouldn't start with syntax or loops. They'd start by using AI to build apps that actually work. Websites, chatbots, data dashboards, real tangible results in minutes. The goal isn't to replace fundamentals, it's to ignite curiosity. Let them feel the thrill of creation, then deepen their learning by showing them the architecture beneath the illusion. Once students are hooked with creativity, we can open the curtain and show them what it really takes to make production systems that are reliable, robust, and secure. Too many students meet CS 101, face the 8 Queens problem, or the Towers of Hanoi, and wonder why they're solving puzzles instead of shaping the future. They've already seen AI generate apps in seconds. We should meet them where the wonder lives. To inspire the next generation of computational thinkers, we need to start with AI, the new language of imagination. This concludes the third part of my talk on how generative AI is liberating computational thinking from coding. In part 4, I'll explore how prompt patterns have become the new literacy of computational thinking, modern design blueprints for human AI collaboration, and show how generative AI is now democratizing reasoning and decision-making by serving as everything from a conversational assistant to an operating system that seamlessly connects tools, data, and human intent through the Model Context Protocol.